talking about the moon phases. We've been also talking about how the planets move in the solar system, right?
Yes.
So today we're going to talk about how the Earth and the Sun and the Moon rotate, okay? And how they make seasons, day and night, year, and also how they make the days, the years, and the seasons. Okay. So first we're going to talk about how they make seasons. Okay. So seasons are caused because the Earth is changing to the relationship of the Sun. The Earth travels around the Sun and is called an orbit. Once a year, or 365 days, the Earth orbits the Sun, the amount of sunlight each day. So when it's doing night, when it's coming from night and day, the Earth is orbiting around the Sun. So if it's facing one way, how this is, if it's facing the Sun, then it's daytime. If it's facing away from the Sun, it's nighttime. Okay. So rotation is just one way that the Earth moves. Earth also revolves, or it moves around the Sun. Okay. And then we already talked about gravity. That's the reason why we're down in. That's the reason why we can walk around and all that good stuff. Okay. So because of the gravity. All right. And so this is talking about how the year is and how it orbits around the axis, the orbits. So, and it makes the years around. Because the Earth is shaped like a ball, the sunlight in some areas, like I was telling you, the light is concentrated at temperatures are warm. In other places, the light spreads out over the larger area. Temperatures are cooler. So if the Earth is not tilted on its axis, the same places, it would always receive direct or spread out sunlight. A place will have about the same temperature all year long. But the Earth is tilted. So y'all gotta remember that the Earth is tilted. So it moves around the orbit. Okay. And as the seasonal changes, it's a latitude and altitude of the Earth. The equator. It places the low latitude and always receive direct sunlight. And the low latitude are usually warm, and that's when the dark places, like at night, good night. Okay. So you can kind of see how it works. So it's on its axis. It's already spinning around. It's going from day to night, and as it's spinning, it's going around its orbit to making it winter, fall, summer, and spring. So if it's towards the sun, that's when you get your springs, and when it's away from the sun, that's when you get your winters. Okay, so again, we're talking about the seasons. When the northern hemisphere is tilted towards the sun, like I was saying, the summer is there, and when the hemisphere receives more direct to the sun, that's when you receive the summers. That's why it's more hotter. And then when it's away from the sun, that's when you get your winters, like I was just saying. Okay. So what I want y'all to do is, we're gonna watch this video. This is why I gave you this. As you're watching the video, I want you to be able to answer these questions that I have for you. And kind of, we're going to talk about more about it when we're doing our model. Okay, so the ones that have your model, I want you to go ahead and start cutting out and things like that, as your other group be able to answer your questions, okay? So here's the video.
A day on Earth is a deceivingly simple concept. Today we'll examine that day on Earth in detail, perhaps uncovering a few surprises. A day is the length of time it takes the Earth to spin 360 degrees on its axis. Or is it 361? Here is a simple model showing the Earth, the Sun, and some background stars. The Earth travels around the Sun in an ellipse, with the Sun at one focus. The model, of course, is not to scale. Let's begin our examination at noon one day. The Sun is directly above the red line. That will be our reference point. Watching from a high vantage point, we see the Earth complete 360 degrees of rotation. But during that time, the Earth has also moved a bit in its orbit. So even after a 360-degree turn, the Sun is not directly above the same point on Earth that it was at the beginning of the spin. It is not noon of the next day. The red reference line needs to spin a little more than 360 degrees to get us to noon. The 360-degree rotation is called a sidereal day, while the noon to noon rotation is called a solar day. Earth orbits the Sun once or about every 366.26 sidereal days, and once for every 365.26 solar days. Not only that, the length of the solar day varies throughout the year, and for two different reasons. First, because of its orbit is an ellipse and not a circle, the Earth moves faster when it is near the Sun and slower when it is further from the Sun. So the little extra amount of rotation that the Earth needs to do to get from noon to noon changes throughout the year. Second, because the Earth is tilted on its axis, the little extra rotation to get from noon to noon is largest at the solstices and smallest at the equinoxes. So solar days grow progressively longer as we move from equinox, March and September, to solstice, June and December. And did we mention the Earth's spin is slowing down and the length of the solar day is increasing due to gravitational ties between the Earth and the Moon? The length of the mean solar day is increasing at a rate of approximately 1.4 milliseconds every century. 2 billion years ago, there were about 750 days in a year. Now let's talk about daytime. That period out of 24 hours when it is light outside. Day versus night. Due to refraction and scattering of light by the atmosphere, there can be daylight even when the Sun is slightly below the horizon. But day length is usually about the Sun's disk being on or above the horizon. So the day begins the moment the Sun's disk appears during sunrise.
So make sure you can be answering some other questions.
And ends the moment the Sun's disk disappears during sunset. At the equator, daytime and nighttime are equal to within a few minutes. But at distances north and south of the equator, the length of the day varies with the season, with the longest and shortest days being on the solstices. At the poles, once the sun has risen, it stays up for 6 months before it sets again. And during the course of each day, it travels in a complete circle around the edge of the sky. Because the Earth travels at different speeds in its orbit, the sun is north of the equator for almost 4 days more than half the year, and the length of the average day in the northern hemisphere exceeds the length of the average day in the southern hemisphere by a few minutes. In the northern hemisphere, the Arctic Circle is the southernmost latitude where 24-hour daylight can occur at least 1 day in a year. In the southern hemisphere, the Antarctic Circle is the northernmost latitude where 24-hour daylight can occur at least 1 day in a year. And daylight savings time is like the old man who cut off one end of the blanket and sewed it on the other end to make it longer.
Alright, so some of y'all can already be answering the question. So what I want you to do is get with your group and try to see if you can answer the question together. So we have 5 questions that the video kind of answered for you. So get together. The people that are modeling, y'all can start putting that together. Just answer the question. So y'all can go together. So go ahead, talk with your group. Alright, so you got to try to Desmond, you need to be working with Orlando. Please don't let him do all the work and y'all just copying. You're supposed to be working together. And hear the huh? Are you helping Orlando? Orlando can't do all the work. Are you working with them? Is she working with them? So one person the rest is
here's the sun, here's your look, rotating right on the tilt. So why don't all the parts of the sun, of the earth receive sunlight? Because gravity. And then this is your earth.
It's gravity.
Here's your all the parts of the earth receive the same amount. No, I don't want to see that. I like her shoulder. Number 3 says, what part of the earth experiences
Yep, so, actually, I'm still, I think, because I can help you. Then the earth, but you can make it. Alright, so one of y'all can come help her do this. Okay. And then the other people should be in your
I see y'all. Why not all parts of the earth receive? No. So why is
right here. You gotta figure it out. Right here. That's the point. Help him. I'm not available. Alright, so you just got the other side? Alright, so how does y'all work? Alright, what you figuring out? I got it. This is what? The moon. Okay, so what do you think the moon is? This is the sun. This is the earth. Right? What do you think the moon does? The sun rotates. Yes. Yes, ma'am.
Where do we put the AC?
Alright, so what do you want? Alright, so I'm gonna give you 4 more minutes. 4 more minutes, and then we're gonna go over the question.
No, she's doing something. Sit down.
How do you know, Larry? We're having daytime on this side, why are they having night on this side? Pointing at the what? Not pointing at, that's over here making this light. What is this thing? Shining.
Alright, so y'all finished answering the question? I'm almost done. And are you still doing it? And it's just like, the reason why you're working in groups is so that everybody can answer one question or 2 questions, and then y'all can work together to answer those types of questions.
Oh, wait, not our last one. The sun.
Yeah,
And then it moves right above. And then it
If you can hear my voice stop 1 time, you can hear my voice stop 2 times. Alright, guys. 1 minute. My model people. Hold it up if you're finished. You put it down. 1 minute. Please, y'all supposed to be working together to get the answer. We gotta go over the answer.
So this. What goes here, Jack? What goes right here? Closest to the earth.
Alright. Alright, go ahead and start going back to your seat.
What is this?
If you're not at your seat, go ahead and start going back to your seat.
You look good. Okay. Makaya group. Alright, so number one. What is the answer? What is the answer to number one? It says, how does the amount of sunlight changes as the earth rotates? How
It goes around slowly.
How does the amount of sunlight changes as the earth rotates?
It goes around slowly.
It goes around. What goes around slowly?
The sun. The earth.
Somebody got another answer? Felicia, your group. Group number one.
24
Felicia.
hours.
Huh?
24 hours.
It goes. It says, how does the amount of sunlight changes as the earth rotates? How the amount of time. So basically, they want to know how does it changes? How does the sun changes? Like the light of it.
Because the earth tilts.
Yeah, it is because the earth tilts. But so it is because of the earth tilts. But they're looking for how it gets darker on one end and how it gets lighter on the other end. Right? I'm telling y'all the answer. It's how you get darker, how it gets darker on one when it's on one side and how it gets lighter on the other side. Okay? I already answered. Alright, number two, Avery group. Number two, why don't all parts of the earth receive the same amount of sunlight?
Because the earth orbits around the sun.
Yes, good job, thanks. Number three, Jalen group. Okay, Orlando, do your group have number three?
Yes.
Why part of the earth experience night and how do you know?
Because the west is experiencing nighttime because we're on the east, and the east is experiencing daytime.
Okay, Avery, what do y'all have?
We have one part is facing the sun and the other is not.
All right, so one part is facing the sun and the other part is not. Good job. The sun appears to move across the sky each day, rising from the east and settling in the west. What causes the motion? What causes it? Anybody? Any group?
Gravity.
It moves in motion because the earth. Okay, so how the earth moves? That's correct. But how does it move?
Slowly.
rotates and what else? Yeah. It rotates and in orbit. So it rotates in orbits, right? Or it revolves as it goes. Alright. Why do you think the moon and star appear to move across the Earth's sky each night? Okay, good job. Alright, good job. So my people that have their model, Felicia, you wanna come up here and demonstrate the how everything's revolve around each other or have a relationship with each other? No. Alright, Sydney. No, this is the way. The sun, okay. And so as the moon is moving, right? So as the earth is moving, so is the what? So is the moon. Alright, okay. You wanna do right? Alright. You finished with yours?
Okay, so first, this is the moon and the earth and the moon. Wait, the sun. This is the sun and this is the earth and this is the moon. It goes around slowly and slow.
Okay, and as the earth is going around, what is the moon?
It's going around too.
Great. You wanna do it? Alright.